All right, let's take a look at some of these useful string methods. So here I've got a variable, full name with my name. And note that there is a whitespace character at the end of this string. So first, let's take a look at the trim method. Trim gets rid of the whitespace at the beginning or at the end of a string. So, console the right line. I'm going to use a format string here. So, 2 single quotes, and I'm going to put a placeholder here. The reason for that is because I want to enclose my string with single quotes so you can see the effect of trim method. Now let's apply some value here. So full name dot trim. Okay, let's run the application. Note that the white space at the end of my name is gone. So this is very important when you receive input from the user. Sometimes you need to trim a string before doing processing on that. Otherwise, if you're going to compare that string with another string, comparison is not going to work. All right, let's take a look at the toUpper method. So I'm going to duplicate this line and change the label toUpper. Note that here we can chain these methods because each of these methods on the string class return a new string. They do not modify the original string. And that's what I meant by strings being immutable. So dot toUpper. Let's run the application. There you go. Now let's say we want to break this string into first name and last name. How do we do that? There are a couple of different ways. One way is to look for the index of the space, and based on that, split that string into 2 parts. So let's try that first. So full name dot index of, you can supply a character or a string here. So I'm going to use a whitespace character. Now based on this index, we want to split the string. So we can declare first name as full name dot substring. Now this method has 2 overloads. Look, the first one takes only an index, which is the starting index. So it starts from that index and goes to the end of the string. The second overload here takes a start index and a length, that is the number of characters to include. So I'm going to use this overload to take the first name. What is my starting index? That's 0, the beginning of the string. How many characters do we want? Up to the index of space. So that's going to be index. And last name. Now this time I'm going to use the first overload. So I'm going to start from index plus 1 all the way to the end of the string. Let's put these on the console. Okay. There you go. So first name Mosh and last name Hamedani. Now there is an easier way to achieve the same thing, and that's using the split method. So if we call split, we can supply a character or a string here. So if I supply the whitespace character here, look what we get in the result. The return type of this method is a string array. So I store the result in a variable called names. So if I hover my mouse over var, look, it's a string array. Now I can easily get the first name as names of 0 and last name is going to be names of 1. Let's run the application. There you go. We got the exact same result. So if you're working in scenarios where you want to split strings, the split method is easier to work with. Otherwise, if you have some more complex processing, you can use the index of and substring methods. Now let's take a look at the replace method. Let's say we want to replace my name here, Mosh, with my actual first name, which is Moshfegh. So, full name dot replace Mosh with Moshfegh. Again, here you can supply a character or a string. For example, you can say, let me show you another example. You can say replace lowercase o with uppercase O. Or you can say replace white space with nothing, with an empty character. And this is exactly the effect of applying the trim method. Okay? Now, the important thing to remember is, as I told you before, all these method calls return new strings. So the original string is not affected. So let me get rid of these two lines here and display this on the console. Run the application. Look, Moshfegh Hamedani. Now let's take a look at a couple of useful methods to work with empty strings or nulls. So in real-world applications, sometimes when you get input from the user, you want to see if the user actually put a value there or not. For example, imagine you're building a form and the user is supposed to supply a credit card number. You want to make sure that the user did enter a credit card number. So how do we validate that? Let me show you. So look, if string is null or empty, so this is a static method on the string class, and it takes a parameter. I can supply null here, and here we display an invalid message. So what do you think is the output of this program? We should get the invalid message because here I have passed null as an argument. So let's just verify that before we go to the next step. Okay, we got the invalid message here. Now, what if I put an empty string? We should still get the invalid message. Look, it's here. So far, so good. But what if the user just enters a space like this? Technically, this is invalid. This is not a valid credit card number. So this is equivalent to user not providing any numbers at all. Let's run the application. Look, we no longer see the invalid message here. So this method was one of the first methods that Microsoft put in .NET Framework. So to work around this problem, what we had to do was trim the string first and then pass it to isNull or empty method. Let's run the application. Okay, we see the invalid message now. But this is a little bit tedious and ugly. That's why in later versions, Microsoft introduced a new method. isNull or whitespace. Now we no longer have to trim. So if the string is empty or whitespace or null, we're going to get the invalid message. There you go. And before we finish this lecture, let me show you how to convert numbers to strings and vice versa. So let's say we receive a number from the user. And if you're building web or desktop or mobile applications, always these inputs come as a string. So you need to convert that to a number. Let's say we get an input, which is the user's age. Let's say 25. So we need to convert this string representation of number 25 into an actual number. There are two ways to do this. One way is to use the convert class. This class has a number of methods and they all start with 2. Like 2 in 32, 2 in 64, to double, to decimal, to date time, to char, to byte, to boolean, and so on. So in this case, if I want to convert this str to, let's say, an integer, I would use convert to int 32. Now, integer is 4 bytes, and we only need 1 byte to store someone's age, because no one can be older than 250 years old. So then we can change this to 2 byte. And now we can store the result here and display it on the console. Now let's take a look at the other situation. We have a number, we want to convert it to a string. So let's say we've got a price here, and that is $29.95. We want to convert this to a string. We can use price dot toString. So every object in .NET has a toString method. The reason for that is beyond the scope of this course, and that's something that I have covered in my C# intermediate course. For now, just remember this toString method is available everywhere. Now, you can call this method without any argument, which simply returns a string representation of this number. But I want to format this as currency. So I supply a format string. So here in the IntelliSense, look, capital C is currency. And by default, it has 2 digits after decimal point. If you don't want decimal point, you can use C0. Or if you want one number after decimal point, you can use C1. So let's just convert this to currency and display the result on the console. Okay, so there you go, $29.95, and we get the dollar sign. Now let's get rid of the decimal points. So I put 0. So it rounded that to $30. Okay, that brings us to the end of this lecture. I hope you enjoyed, and thank you for watching.